What's up, math scholars? It's our third and final day making a video for air review. So who's been having fun doing air review? Woo! I think they've had it with air review. See it on their faces. All right, so we're going to start with some graphing arms. Do you have your graphing arms in class? Did you bring them from home? Let me see a positive slope. Let me see a negative slope. Let me see a zero slope. Let me see an undefined slope. Let me see exponential growth. Exponential growth will be starting low and then growing real fast up this way. And let's see exponential decay. And let's see a right side up parabola. And let's see an upside down parabola. So that's what we're going to look at today. Exponential growth, exponential decay, and then parabolas. So for exponential growth and decay, this is your general equation. Y equals A times B to the X, where Y is kind of like your total. A would be your starting amount, like your starting amount of rabbits, if you're doing rabbits or something. I wrote starting amount of money. Even. B would be the growth factor, and X is normally like time, like how many time periods have gone by that you have doubled or tripled or whatever you're doing. Everyone has a packet 3? Alright, this is probably the hardest part for people, just thinking about what the growth factor would be. So I'll just give you a couple example problems. Let's say I have a bank account and my bank account is growing 5% every year. And it's your responsibility to come up with the growth factor, right? What you're going to do is do 100% plus 5%. Get yourself 105% and then turn that number into a decimal. You know what that would be as decimal? 1.05. That would be your growth factor. Does that make sense? Kind of, sort of, maybe? Do you remember doing this at all? All right. On the other hand, let's say I have something losing value. Cars lose value a lot of times. So let's say I have a car and it's losing 15% in value every single year. What you would do is take your 100%, subtract 15%. That's going to be 85%. 85%. And then you would turn that to a decimal. So what would your growth factor be in that case? 0.85. There you go. Okay. So we'll see a couple of those scenarios today, but I just wanted to give you a heads up on how you do that with the whole adding and subtracting from 100%. And then the growth factors, if they're doubling or tripling, are easy. Doubling is your growth factor is a 2. Tripling, your growth factor is a 3. And then the last thing is the word asymptote. Such a weird word. Say it, asymptote. Hyperbola, asymptote, parabola. There's so many weird words. An asymptote is an invisible boundary line that these growth and decay equations have that sit there on the x-axis. It just makes it so the graph can get real close but cannot touch. Hopefully you remember those. All right, let's go into Desmos and put this data in. We're going to make a scatter plot, and then we're going to make an exponential growth curve to kind of fit our data. This is a scatter plot. Our line we're going to make is not going to be a perfect fit. That's how the scatter plots work. Okay. I'll walk over the computer and give these points up. So 1, 2, 3, 4, 5. Don't tell me you remember. We'll just toggle back and forth. We have to clear it out. We have to grab a table. 1, 2, 3, 4, 5. And then 2, 6, 22, 67, and 300. If you didn't get some of the numbers off the slide, you can look at mine, but here it is. 2, 6, 22, 67, 300. And you can zoom in and out and see where those dots are at. But we want to fit an exponential growth curve, one of these guys, to it. So anytime you're fitting a scatter plot to a line or exponential growth, use that tilde. Remember the tilde? You have to use your y1 and your y2 to tie it to your table. So I'm going to do x, and I do y1 tilde a times b to the x1, like that. kind of see. If you zoom in real far, it looks like a pretty good fit now, but if I keep zooming in, it's not actually touching these points. It's just trying to summarize the trend. Okay. Now this information down here will allow me to write out an equation if I'm interested in writing an equation up. This equation would be y equals the starting point would be 0.21. I'll just round it off. Times the b value would be 4.28. I'm just rounding. And the exponent then would just be that x. Do you think this is a pretty good fitting line? You can kind of look at the r value or the r squared value as well, but it's a pretty good fitting line. 0.999 is a very good fitting line. Any issues with the subscripts or the tilde and getting that your picture to show up? All right, the populations of snails in a tank, and you find this one in your packet, is found to triple every year. Triple every year. What do you think our growth factor is going to be if we're tripling every year? 3. Very good. It counts. Oh, Mark visits the aquarium and counts 80 snails in the tank. That's going to be our starting amount. It says write a function to model the number of snails in the tank n years after the visit. So this is the basic formula we're following. I'll give a ticket away if you can put A in the proper place, B in the proper place, and N in the proper place. Who wants to try this? Anybody want to try for a ticket? We're all looking really tired today. So f of n is basically going to be our y. The 80 is going to be our a, because that's how many snails we're starting with. The 3 is going to be our b, that's our growth factor. And then our exponent for number of years is going to be an n, because they flat out said use an n for years after Mark's visit. Does that make sense? All right, let's scroll down to the next one. The points 0, 1, and 1, 4 are contained in the graph of an equation with only 2 variables. So I went ahead and I plotted these. 0, 1 was here. 1, 4 was here. And you have scrap paper on the air test. You can use your scrap paper to do something like what I'm doing now. You can definitely use your pencil and write things down. All right, let's talk straight lines. How many straight lines do you think I could run through those 2 points? 1 or 2? This is only 1. I saw Sydney like whisper 1, and then she gave a weird look of maybe it's 2. It's only 1. You can only run 1 straight line through there, and it would have a positive slope. Think about your slope arms. So as far as this is concerned, there is exactly 1 equation in the form y equals mx plus b, because that's a straight line that would contain these points. So I would check mark that. We want to check mark all true statements. There's going to be some more. This says that there's 2 equations in the form y equals mx plus b. That is not true. I cannot think of another straight line. I can run through those points. Now these discuss exponential growth curves. Do you think I could fit 1 exponential growth curve to those points? None, 1, or 2. And exponential growth curves look like this. If my board was lined up, I actually would have ran through that second blue dot. But you have to use your imagination there. Okay. Do you think there's a 1 or 2 or 3 or more? What do you think? I'd say only 1 as well. So 1. There you go. All right, what about scientists studying wildlife? She estimates a population of bats in her state to be 270,000. I guess that's going to be our starting amount. She predicts the population to be growing at an annual rate of 2.9%. So we need to figure out what that growth factor is going to be. It's very similar to what we did over there when I talked about bank accounts. If we are growing by 2.9% each year, you have to kind of take into account that you're starting with 100% of the bats you have now, but then growing 2.9% each year. So that's 102.9%. What would that look like as a decimal that I could use as a growth factor? How do I turn a percentage into a decimal? Moo. move it over twice. Yep. So 1.029. There's my b value. And now we're just going to write it as a formula. And then this time they said we can use x's and y's. We don't need to use n's or anything. So y equals 270,000. I think if I was typing in the box, I would not use a comma. I don't even see a comma available. I see a decimal point and a negative sign. Then you could use your multiply sign next, times the b value, which is the growth factor, is 1.029. That's my 2. And the exponent is next. All right. How about you mark those next 3 as ones to do all by yourself for homework? We'll check those for you tomorrow. I want to move on to our parabolas. All right, so parabola arms. A parabola opens up towards the sky if the guy out front is a positive number. So if this A is a positive number, it's opening up. Your parabola is going to be opening down towards the ground if that guy out front, the A value, is a negative. And that's what it kind of talks about here. If A is positive, we open up. If A is negative, we open down. The C value can let you know what the y-intercept is. Y-intercept, back when we did this, was at 0, C. You can just get it by glancing. This is a great topic to use Desmos on. You can just type in these parabolas. You can look for where the vertexes are. With the hover click, you can look for where the intercepts are. The x-intercepts are the solutions. I think that talks about that down here. So like right here and right here, they are x-intercepts. They are called zeros, but they are also solutions to the quadratic. We did have a vertex formula, x equals negative b over 2a. If that would show up, that's the formula. I think you could just get your vertex off of the Desmos, though. Oh, and min and max. Do you remember this? If my parabola is opening up towards the sky, and this is my vertex, would that guy be a minimum or a maximum? Minimum, because it's the bottom of the seriable. I could definitely see them asking a minimum maximum question. And then if it opens down towards the ground, like this, then my vertex is a maximum. Remember doing that in the chapter? All right, let's try some factoring and stuff. Which correctly factored form of this function can be used to identify the zeros? Let's do it by hand first, and we'll use our Desmos to check. So 36, 15, and 6. Do you see any common monomials we can factor out? What do you think? 3. I love that idea. So let's pull a 3 out front, leaving us with a 12x squared, a positive 5x, and a negative 2. How can I finish off factoring this the rest of the way? Old-fashioned method or box method? You remember? It's got that 12. So we're going to want to draw our box. Let's draw the box and just refresh. I know we did some last week. The 12x squared will be in your upper left box, negative 2 in your lower right. Multiply those numbers together to get a negative 24. And now we're brainstorming. We want numbers that will add up to a 5 and multiply to a negative 24. I'll give you a ticket if you can give me the combination. Sammy? Positive. Yeah, perfect. Positive 8, negative 3. She's right. Positive 8 and negative 3. They both get an x. This is for here. We'll pull out what the top row has in common, a 4x. We'll pull out what the bottom row has in common, negative 1. 4 times 3 is 12, so I'll put a 3x here. And 4 times 2 is 8, so I'll put a 2 right here. Looks like my answer is a 4x minus 1 with a 3x plus 2. That's what I had on my side and the top of my box. I can't lose my puppy. Get that 3 as well. C. You're probably wondering, I heard Harp mention she could use Desmos to check. You can absolutely use Desmos in a problem like this. What I'm going to do is graph the original equation. Then I'm just going to graph all of these equations and see which one is the exact same parabola. Does that make sense? Let's try real quick. So 36x squared plus 15x minus 6. Clear out all my old stuff. Got these y equals. instead of f of x equals. But 36x squared plus 15x minus 6. So there's that parabola. I'll hit home so I can see my zoom, my default zoom. Now you can just go through every single choice and try it. So like I'm just going to go to choice C because I think that's the choice it is. 3, 4x minus 1, 4x minus 1 with 3x plus 2. But see how they graph right on top of each other? Because they're the same exact line. That's a good way to verify, yes, C is the same exact vector force. That would be okay. It says which scatter plot represents something that could be modeled by a quadratic function. So just remember that the word quadratic function means parabola. And then which one of these scatter plots could I use a parabola to fit to it? Can you tell? Definitely C, I believe. I think I covered it up just now. C on your paper. Yep, C. At the time, and I'm thinking what you should do the last 3 all by yourself as well, because you can do almost all those with Desmos helping you out. So let's give you 6 homework problems. That way you're doing it and I'm not doing it. The 3 that were on page 3, and then 3 on the very back. Sound good? All right, so we'll end the video here. Thanks for watching the video, and we'll go over those 6 first thing tomorrow. All right.